Hi, good afternoon. My name is Gareth Stradom. I'm the Gas-Cooled Reactor National Technical Director, and I'll be giving the presentation today on RC number 4. We put out two worker scopes this year, 4.1 and 4.2. So let me go ahead with the first one there. This one is about the behavior of the buffer layer during irradiation exposure. We currently feel that on this modern simulation side, we need more insight in how to correctly model this performance of the tricycle fuel layer, specifically the inner pyrolytic carbon and the buffer layer behavior as a function of time and irradiation exposure. The mechanism here is that under irradiation exposure, the buffer layer actually shrinks radially along the volume and tears away then from the coating layer on the outside. Puts stress on the inner metallic fuel particle, of course, but this eventually leads to attack by the reactive fission products, which is specifically palladium in this case, which then goes ahead and attacks the silicon carbide surface. So one of the issues we have with the modeling and simulation of this process is that a lot of the material properties is not known, either for irradiated or unirradiated materials, and we might have to do parametric sensitivity studies to see what the major contributors of this is. So the task for this year in 4.1 is a request to specifically model then the evolution as a function of neutron irradiation of this buffer inner pyrolytic carbon layer, and specifically a time-dependent simulation of how this buffer layer shrinks and densifies. This qualifies for the usual 800,000 up to 3 years for 4.1. So as opposed to the year before, we are specifically targeting modeling and simulation, development of new models here. There is a reference here to an INL report that Blaise and Bill did earlier in 2018. There are factors already identified that has big impacts on this evolution and failure mechanism, so we would advise that people take a look at that has been published before. In addition, we want the parametric studies that perform, since a lot of these properties are not known, you would probably need to run through a series of sensitivity studies, statistical models to figure out what the big impact parametric hitters are for this, because in a lot of cases, the properties do not exist. The second bullet there on this slide talks about obtaining the boundary conditions. Here we would recommend that people go out to the vendors and core designers outside and try and obtain realistic temperature ranges, dose ranges, damage rates, and so forth. So although we indicate that the primary objective of this year's call is to develop new modeling and simulation, we do see that proposals may suggest separate effect experiments where you target a specific material property and correlation that can be developed. You can use surrogate tests with experimental non-irradiated tricycle fuel specimens, new measurement techniques that could potentially be used in glove boxes or hot cells. On the microscopy side, we would advise that you actually try and work with us at INL from the AGR program and obtain irradiated specimens so that we can exactly develop models based on the irradiation properties. The PIE, SEM, and TEM work that's available at various NSUF facilities is advised that you contact the people there and make use of the equipment that's already available. So we recommend on the suggestion side that you contact the AGR field people at Oak Ridge and at INL to try and get access to the specimens as appropriate, and also that there's a discussion with the vendors to get the boundary conditions. On the second 4.2 call this year, we have motivation for research here behind the shuffle of fuel through either a prismatic, a gas-cooled pebble bed or a molten salt design. As you would know, the moving fuel requires measurement of burn-up, since they get either recirculated to the top of the core or they're put back into the spent fuel container, And you can see on the right the diagram here with the fresh fuel container, which is the supply chain. So at the bottom of this is typically some kind of a burn-up monitoring system. So this scope of work here is about tagging, identifying, if you want, the pebbles as they cycle through this core. We need to be able to do that to avoid excessive burn-up, determine the individual residence time in the core, and we also want to cut down on uncertainties we have for the flow line computational models in a code like VSOP. So the focus here should be on a robust, reliable tagging method. And the focus on robust means that these pebbles experience a lot of stresses. It gets abraded. The surfaces, techniques that will use only surface materials will eventually degrade over time. It experiences a very high temperature, high flux environment in these pebble beds. The typical bed consists of 300,000 to 400,000 pebbles. So we're talking about collecting a large amount of data on these moving pebbles as a function of time. It's got to be able to interact with either neutron or gamma or a combination of both measurement systems. And it needs to be rapidly responding to a function of space and time as the pebbles move. So the call here is for either computational algorithms or models that use some kind of a pebble tagging and tracking method. The important point for this year's call is it's not about actually developing the actual system that will measure this, the burn-up measuring system. It's more about the algorithm and the method behind this. So in summary then, the two proposals, the idea behind them is, please look at the websites listed below, both the NUP side and then the art specific side on what has been done before. We are not looking for just save as kind of repeat proposals from the earlier years. You may repeat some experimental work in terms of new measurement techniques that you apply in your methodology. On RC 4.1, we strongly encourage applicants, proposals, to look at the AGR TRISO field program and use the results already available to benchmark your new correlations or models. And on RC 4.2 on the pebble tracking, they should not develop a burn-up monitoring system itself, but rather on the methodology for that. On the data side, under the QA system, we do point out already here that the data collection, validation, everything you collect in regard to this needs to be compliant with NQ1 and some NRC accepted language there for quality control. The exact requirements will be specified in the documentation itself, but loosely speaking, it is quite a tight quality regime. Then at INL, you might be aware that we have a data collection system. It's called NDMAS, where we collect all this data and it's available for anyone that applies to the proposals. So we encourage you to use this as a data storage system as well. So our federal contact is Hannah Lee here in the GCR program, and Paul Demkowitz is the technical lead here, technical manager of the AGR TRISO program. So you're welcome to contact them for more detail. Thank you very much.
Thanks. We will take questions over the next few minutes. Please submit those in the question and answer box on the GoToWebinar application. We have our first question. For RC 4.1, is a multi-scale, multi-physics model in moose, marmot, bison a valid approach? Or is there a recommended code to use on this side?
Not at all. We do not want to prescribe any codes at this point. We welcome proposals that use the latest, greatest, at the legacy in the form of perfume, codes that might be similar to that outside. But we actually encourage people to try and use the latest NIEMS developed tools if they can.
Also for RC 4.1, can you please elaborate more on the statistical analysis? Buffering, shrinking as a function of time irradiation and various boundary conditions?
Yeah, sure. At the end of the day, the stochastic cores are all statistical based, right? Some of the statistical engines like Dakota or Raven is capable of performing many parametric studies using reduced order models, for example. So we would recommend that by the lack of current material correlations, some of the properties are really not known. So we would suggest you choose a lower and upper bound and sample with a normal or uniform distribution between the bounds, and push that through a statistical code wrapper like Raven or Dakota. This is caused mainly by the lack of good quality material information currently available for these properties.
We'll stay on the line for about 15, 20 more seconds with Gerhard. If you do have questions, please submit them now. Also for the RC 4.1 work scope, does it involve any tests or effects of irradiation on buffer or IPYC properties?
We would prefer that the existing database from the AGR program at INL first be explored. There's a lot of data available from AGR1 right through 567 already. So please work through that first before suggesting new experiments that will be performed outside of that. That was mostly the purpose of the call in 2018. So in 2019, existing data sets to be evaluated first, models to be set up, instead of the focus on experimental work. So we want to make that clear. The difference this year is more on the modeling and simulation side than the experimental side.
Okay, those appear to be all the questions we have. Thank you for being here. We will pick back up with our final presentation of the webinar at 2 p.m. Eastern Time. We'll be hearing from Tim Bevel on the Advanced Small Modular Reactor Program. Thank you.
Thank you.